Up next, I would like to invite Vivek. Thank you very much. Vivek is the VP of product at NexStem, and he will talk to us and share some insights about the brain-machine interface. Um,
Awesome.
that's good. The stage is yours, dear Vivek.
Thank you. Thank you. Hi, everyone. Hope you're having a great day. I'm Vivek Raja. I'm VP of Product at NextStem. And today's talk is going to be about what is brain-computer interfacing. So I'll just walk you through what is brain capable of and what is brain-computer interfacing is about and what are the use cases that it deals with. And at the end, we are going to mark an important point that how NextStem is going to enable every one of you here to create any brain computer interfacing device or an application. For example, just let's put a thought. How about you communicate with Alexa or Siri on every daily basis, right? So how about you communicate with Alexa and Siri hereafter with just your thoughts, not your voice commands? Sounds interesting, right? So let's hop into the session. So first of all, to know how our brain-computer interfacing works, we need to understand how what a brain is capable of doing it. So our brain is very complex, as you all know, one of the complex organs that do ever exist, and it controls your memory, your emotions, your motor skills, if you want to move your arm, if you want to talk, if you want to do, and also controls your vision, how you are capable of seeing it, breathing, temperature, hunger. It basically regulates your entire body. So now we know what this brain is capable of doing. So let's now understand how this brain-computer interfacing actually works. So brain-computer interfacing is where a system or something, an acquisition system that you can consider that will acquire your brain signals, that will analyze it, and it will able to understand what command that you're actually planning to give. And this command is translated to your end device or your end application so that that device carries out your recommended command. So basically it bypasses your action and it takes your command directly and it passes to your output systems. So that is what is called a brain computer interfacing, to be put in very short. And to just put the BCI pipeline into simple steps, we can just call it into 4 steps, where first is signal acquisition. So that is where you acquire your brain signals, and the feature extraction. So your brain is capable of throwing multiple signals or able to think about more than one thing at a particular point of time. So if you want to concentrate on which command that you want to really listen to, that's where extraction comes into picture. And the translation is where how do you make those brain commands more compatible that you can pass it down to your device in such a way. So that's your feature translation. And then your device or your application or whatsoever that wants to be controlled by your brain can receive that command and carry it over. So that's simple 4-step process of any BCI. So just deep dive into that. So the first one is signal acquisition. So it's where how we collect the brain signals from your devices. So there are 2 ways to do it. One is invasive, one is non-invasive. So you might be wondering that why I am actually taking a lecture on how these stuff, but eventually that will help you to create your own BCI devices at the end. So there are 2 ways to do it. So one is invasive. So you might have heard about Neuralink, that from Elon Musk, where he plants your chip inside your brain. So that's one way of doing it. And the rest of the people who do that is using non-invasive sensors. So we place something like this, a headset that is on your head, and that will be able to capture your brain signals. So that is what NextStem does. The second part is feature extraction. So to analyze which command that I want to really listen to is what the feature extraction comes into picture. So here we collect EEG data, which is nothing but your electroencephalogram, which is nothing but your brain signals, and that is collected by your signal acquisition device, or you call it as an EEG headset. And once you collect this headset, that's where you analyze this particular data and you pick out this particular artifacts that you really want to listen to. So that's feature extraction. And the next one is feature translation. So now you have some an extracted feature that you want to translate so that your end devices can understand and carry out that particular command, right? So that's feature translation. That's where your entirety of your machine learning or deep learning stuff comes into picture. So because since your brain is complex and all these features are really complex, you need some mechanism for you to translate or map those features into